Hi guys, welcome back to my channel. For those of you who don't know, my name is Jag, and this channel is basically all about mathematics and science at the high school level. So let's start off. Today's class is grade 9 science, and we're going to cover how to draw the Bohr Rutherford diagrams. Alright, so before we try this example, I just want to write down a couple of rules, that we need to remember when we are drawing the Bohr Rutherford diagram, What this diagram is it shows the number of electrons that are present within an atom of each element in the periodic table. So the first rule is going to be, I'm drawing energy shells. On each of these energy shells, I'm going to show the number of electrons, So here in the first energy shell, the first energy shell can only hold up to 2 electrons, So what I'm going to put here is 2e. And this is how your teacher will most likely denote the number of electrons, Remember that electrons have a negative charge, whereas the protons have a positive charge, alright? The second main rule I have to remember is each of the energy shells after the first shell that you're drawing can only hold up to 8 electrons, So let's put each energy shell, I'm going to put each energy shell after holds a maximum of 8 electrons, So each energy shell cannot have more than 8 electrons on it, alright? So these are the two rules that I need to just remember for now, And even if you're a little confused, we're going to go through this example on the board, So I'm going to take off the rules so we have some room here. And so this is the example that we're going to try. We're going to try sodium, And whenever you're doing these questions, I should make sure I have a periodic table open in front of me, So if I'm looking at sodium, sodium has an atomic number of 11. So if you look in the periodic table here, so I have one open in front of me, I'm looking at sodium, and in each box you'll see 2 separate numbers. The smaller number is the atomic number, And that bigger number is actually the mass, It's the atomic mass. So how much does that atom of that element weigh, So here I'm also going to write out, the mass number for sodium, which is 23. So let's just go through what this means here, So the atomic number indicates the number of protons, of the elements. So I'm going to write P equals 11. For the Bohr Rutherford diagram, what is important is the number of electrons. And in this case, because the atom is electrically neutral, the number of protons will be equal to the number of electrons, alright? So the electrons, I'm going to put 11, alright? And now the second part here is going to be the number of neutrons, What I'm going to do for the neutrons is I'm taking the mass number, I'm going to subtract the atomic number. So in this example, it's 23, minus 11, which is equal to 12. So the mass number actually indicates the protons plus the number of neutrons, whereas the atomic number gives you the number of protons. So that's why when you subtract the two numbers, it's going to give you the number of neutrons. Are there any questions there? Good. So let's get started. What we're going to do here is I'm going to just take off this last part, And what we're drawing is basically just the number of electrons, That's what we're showing in the Bohr Rutherford diagram. So I'm going to draw a circle here, And we're going to write down the number of protons, which is 11. So I'm going to put 11p, I also have to indicate the number of neutrons, and that's why we showed the calculation on the board, So the neutrons is 12, so we're going to put 12n, So this first circle represents the nucleus. I'm not going to draw any electrons on it. So I'm going to go to the first shell here, So remember from the rules, the first shell can only hold 2 electrons, I'm going to draw 2 electrons on it. And what do you notice about my diagram so far? So if you're looking really closely, You notice I'm not drawing the two dots right beside each other, okay? Because these are electrons, and electrons have a negative charge, okay? What that means is that the electrons, just like the laws of physics here, the like charges are going to repel each other, so they're going to go in the opposite direction. They're going to be as far away from each other as possible. So you have to draw your Bohr Rutherford diagram like this, or your teacher might take off marks for that, okay? So you don't want that. I'm going to go to the next energy shell. So again, the first shell here can only hold 2 electrons. So now I'm going to move on. I actually have to draw 11 electrons here, okay? So what you're going to do is just count it out. So there are 2 electrons here. So 3, 4, okay, 5, 6. I can still draw up to 8 electrons, okay? So I'm at 6 here, 7, 8, 9, and 10. Okay, so I just want to stop there for a second. You should have noticed how I'm actually drawing these electrons, okay? I'm not just drawing 2 of them together. I have to start at the 12 o'clock position. I'm going in the clockwise direction when I'm drawing the electrons, okay? So you're drawing 1 at the 12 o'clock position, okay? Then the 3 o'clock position, the 6, and then the 9 o'clock position. And then when you have 4 electrons as far away from each other as possible, okay, the atom is basically stable there. And then I can start pairing up the electrons until I get a maximum of 8 electrons, okay? So right here, we have 10 electrons. I'm going to draw the next energy shell here, okay? And this is 11 electrons. So this is actually the Bohr Rutherford diagram, okay, that I'm drawing for sodium, okay? And we're just going to define a couple of terms here, okay? This outermost shell is actually called the valence shell, okay? Which means it's just the outermost shell in the element. And it's going to be different for the various elements in the periodic table. And if you look at this electron that's found on the valence shell, okay, this is called the valence electron. So your teacher is always going to use terms like this. I have to make sure I understand what the term valence actually means and what the teacher is referring to, okay, when he or she says valence shell or valence electron. Okay, so again, just to sum up here, this is how you're drawing the Bohr Rutherford diagram. The rules, first you should start off by basically writing down how many protons, electrons, and neutrons the element contains, okay? And for that, I'm just checking in the periodic table, okay? When I'm drawing out the Bohr Rutherford diagram, the first circle always represents the nucleus. I have to make sure I'm writing the protons and the neutrons inside the nucleus, okay? So because this element is going to be a neutral element, it doesn't have a charge, okay? That means the protons have to equal to the number of electrons. Okay, so the atomic number just indicates the electrons I'm going to draw, all right? And we're looking at this diagram here, okay? The first shell can only hold 2 electrons. After that, each subsequent energy shell can hold up to a maximum of 8 electrons. Okay, after 8 electrons, I have to just move to the next energy shell. Okay, so this was the example that we did for sodium. And if there are no questions, that brings our video to an end. I hope you learned something. And if you did, please again, click on the like button below and subscribe to the channel so I can bring out more content associated with grade 9 science. So thank you for watching, and I will see everyone next time. Bye.